Now, so far, we really have only discussed bottom-up type approaches, both the Geon theory, well, the template matching, the Geon's theory, and the pandemonium model type approach, the connectionist approach. They all really were only seen in their bottom-up functioning, meaning information comes in and you analyze it in order to understand which of a number of templates it best matches. However, it's well known that so-called top-down factors are very important in recognition. Specifically, context is often very important. Read these two sentences. In fact, read the first one and read the second one. I think that if I were to poll you on the question down here, what's the last word of these two sentences? Up here, you probably thought fed, whereas down here, you probably thought red. Now, what is interesting is that if you look at this word here and this word here, it's the exact same information that is hitting your retina. The lines here and the lines here are exactly placed in the same position. And yet, you recognize the this as the word bed with very little trouble, and you recognize the this as the word red with very little trouble. So how could it be that given the incoming information is exactly the same, how could it be that you are deriving different interpretations of what is written there? Well, the answer is top-down effects or context effects. It is well known that our brains, our minds, use context in order to analyze the information that is brought in. Our minds use information that we already know in order to guide the analysis and processing of the incoming information. Here's one example. It is known as the word superiority effect. It's the finding that people tend to be much more accurate in recognizing letters if they are in a context of a word, as opposed to either by themselves or in the context of a random string of letters. Let me show you what the experiment might look like. So you're a participant and you're looking at a screen. The screen is blank. And then I flash very quickly either a letter or a string of letters. And in one case, I might show this, LXOD. And your job is just to tell me what's the letter inside the red square. So I flash this very briefly, very quickly, just some hundreds of milliseconds, just enough for you to see it. And then you have to answer as quickly as possible, was the last letter a D or a K? And then, you'll perform at a certain, you'll respond at a certain speed. But then here's the different condition. Instead of flashing on screen quickly LXOD, I will do the exact same, but I will flash the word load. Again, it doesn't matter what the word is. Your task is just to tell me, is the last letter a D or a K? Turns out, when you have to respond to the exact same question in the context of the word load, participants typically perform better than if they were shown the word LXOD or just D by itself. So clearly, context is allowing you to process somehow more fluidly and faster the incoming information. What is interesting is that connectionist type models, such as the pandemonium model that we saw earlier, are able to account for this with top-down effects. Here's how this would work. And this is the simplified version of the pandemonium model, just to explain this particular phenomenon. Let's say that you see the string LXOD, and again, your task is just to tell me if this is a D or a K. So this comes into our so-called image daemon, and it will activate the features that it finds. For example, it might activate the vertical line and the little circle-y line. In turn, these two features will activate, well, the vertical one will activate the D, the K, and the L, presumably, and who knows, many other letters that I'm just not showing here. And then the O would activate the D and the O. So of course, after having decomposed what came in into its features, in its two-dimensional features, and then having matched that to letters, um, your mind will say, okay, the most active one of them all is a D, so I'm probably seeing a D. Now let's see what happens if we change this and we give it the context load. Now, of course, the exact same thing happens. However, you will also get, the truth is that these other letters are also getting processed in parallel. So for example, the presence of the A will activate a little bit the letter A, and so on and so forth. And your mind will notice that actually here, there are all the letters activated to some degree, all the letters that form the word load. Now that your brain has seen that the word load is there, what it can do in a top-down way, it will activate even more the D. So the D is now activated 3 times, even stronger than before. So of course, your answer, D, will be stronger than before, will be faster than before. So this is how you can account for top-down factors in these type of connectionist models. And finally, the context in general just seems to have a very strong effect on how we process incoming information, meaning top-down effects tend to be fairly general and tend to have to do with context. And this is also known as scene schema, the so-called facilitation effect that can be attributed to the fact that people typically learn to see objects in certain contexts. Here's a wonderful example by Barinholtz, who's the author, the main author of the book we're using. And what he did with his collaborators is he took different scenes. In fact, he showed the same object, an apple, sometimes with no context, sometimes in an unfamiliar context, and sometimes in a very familiar context, among other fruits, let's say. And he showed these images at different degrees of granularity. Some were really, really sharp, like here, and some were really crummy, like this one. And so the question is, how well defined does the image of something have to be for you to be able to recognize it in these different conditions? Turns out if you're seeing something in no context or in an unfamiliar context, before you're only able to recognize the object once it has good resolution. So once you can really tell, oh yes, okay, that's an apple. So if you have no help from the context, the image of what you're seeing has to be very sharp for you to be able to recognize it. Conversely, if you're seeing something in a familiar context, maybe there's a bowl of fruit there, and there's a banana right nearby it, and some grapes and some oranges. Even though you see a very crummy image of the apple, it is enough for you to recognize it as an apple. And this, of course, has to be entirely a top-down phenomenon. The fact that you're seeing other fruit there makes you think that, yeah, I can't see this very well, but you know what? There's other fruit around, so what could that be? Well, probably an apple. Right? So context plays a very important role. We just happen to learn that things, that certain objects tend to occur in certain contexts. So this is the so-called scene schema. Again, showing the importance of top-down processes in object recognition.